What up, folks? Biggity back again with another code breakdown. This one is a Java exercise, Code Wars once again, called Changeable Diagonal. And it appears that the name is spelled incorrectly, but whatever, it's still a decent exercise. So, right off the bat, just ignore that part of the description, useless information, so we can move down. Extraneous information many times in these things. So look at the task. Given a matrix, which is really a two-dimensional array or list in Python, but this is Java. Two-dimensional, given a matrix and a specified value, a specific value. So you're going to be given a two-dimensional array and a certain value. The value is going to change the main diagonal of the matrix. The main diagonal is basically the trace of the matrix, and it refers to an article. Forget about that junk. The main diagonal of the matrix is the one from the top left to the bottom right. That's the main diagonal. The value that you're given is going to change that main diagonal to a different diagonal. And it'll be either up or down. And the determinant is here. So if the value that you're given along with the matrix is greater than 0, that diagonal goes down. Meaning really the diagonal is going to go from here down to here. Like that would be if the value is 1, it's going to go down 1. So if the value is greater than 0, the diagonal drops down, it's going to go down a row basically. Well, it's going to go down according to the number that you are given. If you're given 1, it's going to drop down 1. If the value is less than 0, it goes up actually. So if the value is less than 0, it's gonna go from here, it would go up. So like this one would be the new diagonal if it went up 1. So it goes down greater than 0, up less than 0. If it is 0, it doesn't change. So the diagonal stays the same if it is 0. And let's look at the example. I've already looked at it a little bit, of course. Looking at the example, we have a matrix, two-dimensional list, 4 by 4, appears to be. And you see the main diagonal specified. That's the main diagonal. We're given this matrix and a value of 2. And what it's supposed to do, the main diagonal will shift by 2. The value is the shifter. It's going to shift it by a certain amount. So here it's going to shift it by 2. And so if the value is greater than 0, it shifts it down. So it's going to shift it from starting at the 1. It's going to start now at the 9. It's going to go down here if we shift by 2. Come from here down to here, 1 to the 9. That's the shift. And you'll see it play out as I scroll down. See, the main diagonal here is that diagonal. Given a value of 2, you see it shifts down to the 9. So it goes from this diagonal down to this diagonal. The shift went down 2. Make sense? Makes sense to me. Very good. And then the case of the value being negative, and there's still more to say because I haven't told you what to do, but it says it down here. When you get the new diagonal, you got to do something with it. But let me just get through this example. When the value is negative, like a -2, it'll go up. Well, I guess the diagonal will shift up. So it goes from this diagonal to begin, and then it'll go over this diagonal because this is 1 and this would be 2 ahead. So this is your new diagonal, the 3 and the 8. So the 2, it goes up from negative. So if it's less than 0, it goes up. All right, so now given these rules, it says down here, with these rules in effect, find the sum of the trace of the matrix given the value. It's find the sum of the changed diagonal. So this diagonal, 3 plus 8, is going to be 11. I think that's what it is, yeah. And then the one above, is going to be here, 9 and 14. What is that, 23? So yeah, you get the sum of the diagonal. And so I went over how to shift to the diagonal, then you get the sum of the diagonal. Yeah. So that's what it is. So let's keep it moving here with the code. So I'm going to be given a matrix and a value. That's how we're starting this thing off. And in a matrix, or I guess you could say, yeah, matrix, we're always going to start at the top left at 0, 0. I don't know if that's even seeable. We're going to start at the top left, and then you're going to shift either down or up, depending on, this is your main diagonal. Depending on the value that you're given, you're going to shift down or up, but you're always going to start at 0, 0. So my decision is to create variables for the row and the column starting at 0 and 0, like this. Because that's always going to be your starting point. Your starting point is always going to be that main diagonal, 0, 0. And that value is going to shift you either down or over. You see, in the case of if you have a positive number, the row will go down. If you have a negative number, the column will go to the right. That's how it works. And you can use that idea to really just do this exercise. That's the guiding light, so to speak. And then you just get the sum of the diagonal. So how this is going to play out is I'm going to do a conditional where if the value is greater than 0, meaning it's positive, the start row-wise is going to be plus the value, meaning that it's going to go down by that value. If it's positive, it goes downward. So this x would come down rows. If the value is negative, it's going to go over to the column's going to go over to the right. And I'll put that here. Less than 0. And it's going to go over to the right by a positive amount. So even though the value is negative, I got to change it to its absolute value. Because if the value is less than 0, I'm going to shift it over to the right by the value. So this would be negative, this would be positive. I know this may be hard to follow, but I'm trying to kind of do this at a reasonable pace, not sort of fully explaining everything. Bear with me, folks. So And if the value is equal to what is it? If the value is 0, you don't do any change to the main diagonal, so it doesn't change. You just get the sum of that. And that reminds me that we're getting a sum, so we're going to make sum equal to 0. Well, we're going to create let me explain this realistically. We're going to create a variable to put the sum of the diagonal into, and that's what that is. And now I've got to actually do the shifting. Well, actually, I'm going to capture the new diagonal basically with a while loop. And this while loop is really, it's going to be about staying in bounds of the two-dimensional array. Let me clear that. Don't want to get it all. I don't know what I'm saying to myself. Stop talking. Stop talking. All right, this while loop, this is strictly to handle the boundaries of the two-dimensional array. Like, if my row is, while my row is less than the length of the entire array, meaning it's in bounds row-wise, and if it's in bound column-wise, basically, then I can continue. But if it hits the end, I can't go anymore. We're going to be out of bounds. So I'm going to leave it. I got to do it that way. And while I'm in bounds, I'm going to start row and start call are going to change as I move throughout start call throughout this. Because so wherever I start, I'm going to increase these by 1 as I move, because that's how diagonals work. Like, well, let's mark off some. So we got a makeshift matrix here. I guess you really got to do 3 rows to make it decent. But let's say we start with diagonal even kind of doesn't even look right. I don't know. Let's say we start with this diagonal. To go from this element down to this element, I've got to go over 1 and down 1. So the row and the column are going to increase each time. So like if I start here, to go here, I've got to go over and down. That means your column and your row are going to increase. Column, row, increase here. Column, row, increase here. So they've got to go up by 1 to always get to the next thing in the diagonal. So that's really what's happening in this loop, where I get the current element added to the sum, and then I move down. And start row and start column are, and actually, wait a minute, this is wrong. Up here it needs to be start call, because the value is less than 0, I'm moving over 1. And if you don't know, these are starting values for the row and the column, and they're going to, of course, increase as we move to the next thing in the diagonal. I know I'm kind of explaining this piecemeal, but it is what it is. I'm doing this in one take. I usually do these in one take, so bear with me. If you're coding this with me, you can ask me questions, but you can't do that now. Ask me questions in the comments, but nobody really comments on these videos, so well, nobody really watches them either, so there's that. You gotta watch the comment. I'm coding alone. All right, start row, start. That's too many T's. Yeah, so they're gonna both increase, like I said, as they go down. And at the end, you're going to return the sum. All right. I think I got through that one. Hopefully you understand the code. If you didn't understand the explanations, maybe you got a little piece there. My explanation was not linear, but hey, it is what it is. That's nice, isn't it? Leave you hanging. Well, let's see if this thing works. I don't even know if it's all correct completely. Oh yeah, my condition isn't complete there. This thing's all jacked up. Okay. Oh yeah. Incomplete condition. Why didn't you guys say anything? Yeah, because start boundary. So the boundary of the row, the boundary of the column. Yeah. Ramblings of a madman. That's good, and that's good. Yeah, a reasonable solution to this problem. Here is Changeable Diagonal, Java, Code Wars. Let's get it. There's another look at the code. Beautiful. Actually, I like how this turned out. I like the flow of this code. It's not, I don't think it's overly like, I don't think it's too much. I think my solution in Python was kind of like, it was worse than this. So I like this one. This is my second solution. Anyway, that's it for me. And that's it for you. So I am out. See ya.